Good day everyone, we are the group 2 and here is our group presentation for MTEC 101. So my members are the Cadet Bayang Giovanni and the Cadet Cabido Leo Jack Anthony and yours truly the Cadet Batukan Victor Joseph. So next slide. So our course outcome is demonstrate thorough knowledge and understanding of the content, application and intent of great circle sailing. Learning outcome is at the end of the session, the student shall be able to demonstrate and compute great circle sailing problem, specifically solving for the difference in latitude, difference in longitude, great circle distance, initial course angle, initial course through, final course angle, and final course through. Next slide. So our problem is your ship departs from the port of Jurong in Singapore from position latitude 35 degrees 27 minutes north and longitude 139 degrees 39 minutes east. It is bound for Manila, Philippines, specifically Manila North Harbor, at the position of latitude 37 degrees 48 minutes north and longitude 122 degrees 20 minutes east. So the problem is determine the following: difference in longitude, difference in latitude, great circle distance, initial course angle, initial course through, final course angle, final course through. So next slide. So first and foremost, we will solve for the difference in latitude and the difference in longitude. So first is the DLAT. So latitude 1, as in the problem, is 35 degrees 27 minutes north, and latitude 2 is 37 degrees 48 minutes north. So since latitude 2 is bigger, so we will subtract 37 degrees 48 minutes north minus 35 degrees 27 minutes north. So it is subtract because it is the same name, which is north. So DLAT is equal to 2 degrees 21 minutes north. So we'll copy because the direction is going to north. So since latitude 2 is higher, so our DLAT is 2 degrees 21 minutes north. So next is the difference in longitude. So in the problem, longitude 1 is 139 degrees 39 minutes east. Longitude 2 is 122 degrees 20 minutes east. So we'll just subtract because it has the same name, which is east. So 139 degrees 39 minutes east minus 122 degrees 20 minutes east. So we'll have 17 degrees 19 minutes west. It is west because the direction is going to west, because latitude 2 is smaller than latitude 1. So our DLO is 17 degrees 19 minutes west. So next slide please. So after we solve for the DLAT and DLO, we will now solve for the great circle distance. So for the formula of great circle distance, we have cosine GCD, or the great circle distance, is equal to cosine latitude 1 times cosine latitude 2 times cosine DLO plus minus sine latitude 1 times sine latitude 2. So it is plus or minus because if it has the same direction, the latitude has the same direction, it will be plus, and if it is the opposite, it will be minus. So since we have the same latitude, which is north, we'll have plus. So cosine GCD is equal to cosine 35 degrees 27 minutes times cosine 37 degrees 48 minutes times cosine 17 degrees 19 minutes plus sine 35 degrees 27 minutes times sine 37 degrees 48 minutes. So cosine GCD is equal to 0.81462 times 0.79016 times 0.96467. So plus 0.57999 times 0.61291. So we'll just multiply. So now we have cosine GCD is equal to 0.61450 plus 0.35548. So we will now add. So we will get the result of cosine GCD is equal to 0.96998. So after that, so next slide, we will inverse cosine. So in the calculator, we'll just shift cosine. So we'll get GCD is equal to inverse cosine 0.96998. So we'll have GCD is equal to 14 degrees 4.5 minutes. So we will multiply the final answer to 60 to convert it to nautical miles. So GCD is equal to 844.5 nautical miles. So that is all for my report about the DLAT, DLO, and GCD. So the next presenter will be the Cadet Bayang Giovanni.